Hello, I'm John Beach and this is an overview of our innovative process for producing carbon neutral oil. The majority of independent scientists now agree that there is a single threat far greater than any other, which is most likely to lead to the extinction of mankind. And this is the threat of climate change, and at the heart of this is the CO2 problem. We are releasing too much CO2, and this is already causing unnatural climate change and damage to our environment. We're burning too many fossil fuels, which are producing too much CO2 for the Earth to absorb naturally. So when will we start to reduce the burning of these fossil fuels? Well, the data that we're using in the presentation today is from the International Energy Agency and their 2013 report on key world energy statistics. And as you can see, there is no end in sight. The graph shows more and more fuel being used. And the reason for this is oil. It's out of control, and it looks like it'll stay that way for the foreseeable future. So what's using all of that oil? Clearly, the biggest usage, and the one that's increasing faster than any other, is transport. Okay, so oil is the biggest problem and transport is the biggest culprit. But we've got technological solutions that are going to reverse all of this and turn it round, isn't that right? Well, when it comes to electricity production, yes, we do have a whole range of technologies that are helping turn the tide on CO2. And the benefit of these are increasing year on year. But when it comes to transport, our technologies are not making much difference. Just 3.4% of the transport fuel comes from renewable sources. Now, electric vehicles are getting better and better, but they're having a minimal effect on our oil consumption currently. Biofuels, well, they're not holding their own against the general rise in fuel consumption. Hydrogen does promise to be a great fuel for the future, but we haven't solved the technical problems yet, especially when it comes to storage and transport. So the nub of our CO2 problem is oil and the way we use it for transport, with our millions of combustion engines that are addicted to oil. We have no real sustainable solution that allows us to keep those engines running whilst at the same time reducing our CO2. Now, that's a problem. Here at RockFuel, we have invented what we believe is a significant contribution to this technological shortfall. We have invented a cost-efficient, sustainable process that produces carbon neutral oil for use in these existing combustion engines. How? Well, it's pretty simple really. It uses a mixture of ancient and modern technology brought together in a unique process. Let me take you through a non-technical three-step overview of how it works. Step 1. We heat limestone rock to separate it into quicklime and CO2. Step 2. We produce hydrogen and immediately combine it with CO2 to produce syngas, which is then processed into a substitute petrol gasoline for use in existing internal combustion engines. Step 3, we take the quicklime from step 1, infuse it with CO2 from polluted sources, which makes it ready to put back into step 1 again. So in this way, we have a sustainable cycle that continues. Let me just take a little closer look at each of these steps. Step 1 is to produce quicklime and CO2 by heating a very cheap and plentiful resource. and we heat limestone up to 900 degrees centigrade. And this is done in a carbon neutral manner using a RockFuel rotary lime kiln, which is heated by an on-site atomic power source using either steam or electric element. So step one is a real mixture of ancient and modern technologies to produce this innovative process. Step two combines syngas from hydrogen and CO2. Hydrogen is produced using the high temperatures that are economically available from the nuclear reactor using solid oxide electrolysis cells and high temperature electrolysis. Now, new catalysts promise to make high temperature electrolysis even more efficient. A further process option here is to use the sulfur iodine cycle. Each of these processes are already commercially proven. Next, the CO2 and hydrogen are heated under pressure to produce methane using the Sabatier process. And finally, the heat and pressure that exists in the plant after the second stage can be utilised to enable further refinement into methanol. Now, existing internal combustion engines can easily be modified to use ethanol, and the Indy race cars that are popular in the United States are a good example. Further refinement can produce butane and butanol, and the latter is of course a direct replacement for petrol, for which absolutely no engine modification is required at all. Again, a series of processes, all of which are existing technologies and proven. This third step is really sweet. It's the element that makes this solution truly carbon neutral. Quicklime is like a sponge, and it collects CO2 from the atmosphere or from water. And this collection accelerates when it's placed in a hot or moist or polluted environment. And once recharged with CO2, it reforms back into limestone and can be returned to the kiln and processed again and again and again and again. The CO2 collected here offsets the CO2 that's released when the vehicle burns the fuel produced in step two, thereby making the process truly carbon neutral. So that's the process. Our raw materials are rock and water, and by reprocessing the recharged quicklime, we can repeat this process over and over again. There are 5 foundations to this sustainable solution to the CO2 problem. Firstly, science. Now, we have been making quicklime from limestone for thousands of years. It's the making of hydrogen and oxygen from water that keeps our astronauts alive on the space station. So again, another example of everyday science. We were combining CO2 and hydrogen together to make fuel as long ago as World War II. The combination of hydrogen and CO2 into fuel for vehicles is established and uncontroversial. And the ability for quicklime to absorb CO2, well, this is one of the most common experiments taking place in school every year. And we also see it naturally in the world around us as we see putty drying on our windowsills. So each step in this process has been done before. It's the combination and the application that makes this a revolutionary solution. Next, our economic rationale. Now, the production costs of quicklime and hydrogen already exist. Efficiencies of the RockFuel process will be optimised when combined with modular helium-cooled nuclear reactors. However, the Welsh aluminium smelting industry has already proven that on-site conventional nuclear reactors can deliver electricity very economically in order to provide the necessary heat for use in an industrial process. Our economic analysis estimates that RockFuel oil can be produced at $3 per gallon pre-distribution, which will be directly competitive with petrol. Next, our practicality rationale. Now, limestone is cheap and it's plentiful. In fact, it makes up about 10% of the total volume of all sedimentary rocks worldwide. We already quarry limestone for a wide variety of uses, including things like toothpaste and paper and paint and tiles. Our process requires nuclear power and will therefore be located alongside such a facility. The process can utilise off-peak power or steam to further optimise cost efficiencies. Now, hydrogen is difficult to store and transport, but in the RockFuel process it's combined immediately with CO2, thus making it an easy solution to produce our gasoline. Quicklime CO2 collectors can be placed anywhere. They will recharge quicker if placed in highly polluted areas such as road tunnels or exhaust systems or chimneys, or alongside polluting processes such as cement manufacturing. Next, let's have a look at the political rationale. Well, which nation wouldn't want to produce its own oil? The strategic benefits are clear to see, including such things as the balance of payments, where developed nations are adversely affected by the cost of importing crude oil. This is obliterated by those nations able to manufacture their own carbon neutral petrol. RockFuel is a major step forward towards energy self-sufficiency for any country possessing nuclear power, with all the knock-on benefits to economic success and even aiding world peace. Any country producing RockFuel is demonstrating laudable carbon leadership. This may also enable governments to reduce other less cost-efficient green policies while still achieving international emissions targets. Next, environmental. We know that we are using more and more oil, and we know that transport is the biggest culprit of this. RockFuel specifically addresses this issue. It's a practical solution for our millions of existing combustion engines, bringing a significant reduction in CO2. Each of our raw materials and inputs has a low environmental impact. Limestone is all around us, and it doesn't need to be sourced from environmentally sensitive areas, unlike crude oil. The RockFuel process is carbon neutral. So if our combustion still continues to rise as it's expected to, we're not adding to the CO2 levels in the future. So in summary, the science is straightforward. No individual step is revolutionary, but as a whole, the RockFuel process is potentially monumental. RockFuel is competitive with petrol and produced with cheap and plentiful raw materials. RockFuel will be political dynamite, helping individual governments regain control of their economies. It's a sustainable solution to our increasing consumption in transport. RockFuel will have a massive, sustainable environmental impact. Now, we're working together with politicians, scientists, innovators and business to make our goal of RockFuel production a reality. If you have an interest in helping us or getting involved in any way, please contact us via our website. And thank you for watching.